Welcome to aminacademy.com. In physics, let us do some solving problems regarding alternate current. Look at this figure. Shows a series circuit connected across 200 volts. 60 Hz line consists of the capacitor of capacitive resistance 30 ohms and non-inductive resistance of 44 ohms and a coil of inductive resistance 90 ohms and resistance 36 ohms. Determine the current in the circuit, the potential difference across each element, the power factor of the circuit, and the power absorbed by the circuit. Here in figure, those things are given. First one we have to find current in the circuit. For current in the circuit, we have to find Z first. Z equal R1 plus R2 the square plus XL minus XC the square, which is equal R1 is 44, R1 is 44, R2 is 36, the square plus XL, this complete square root, XL is 90 minus 30, 90 minus X is 30 the square, 90 minus 30. Here, which gives 100 ohm, approximately 100 ohms, then which is equal 0.1 kilo ohm. Now current I equal V over Z. V is 200, Z is 100 ohm, which is equal 2 amps. 2 amps current is flowing through the circuit. Next one, the potential difference across each element. Each element you have to calculate. First, PD across capacitor. That is PD equal to I XC. I is 2 amps multiplied by across capacitor. Across capacitor is 30 ohms. Then 30, which is equal 60 volts. PD across resistor, potential difference across resistor is I R1. Across resistors I R1, that is 2 into 44 is 88 volts. Impedance of the coil. Next, third one. Before that impedance of the coil equal R2 square plus XL square, which is equal R2 is 36 square plus 90 square, which is equal 97 ohms impedance. PD across coil, then PD across the coil is equal to 2 amps into 97 ohms, which is equal 1 here 14 on carries 194 volts, which is equal 0.194 kilovolt. Then power factor. Next is we have to find the power factor. Power factor is cos phi, which is equal R over Z. That is 80 over 100 equal 0.8. Power factor is 0.8. Power used. Power used equal VI cos phi, which is equal V is 200 volt, 2 amps, cos phi is 0.8, which is equal 0.320 watts, which is equal 0.32 kilowatt. Then power absorbed, power factor is here, then power used, that is power absorbed, is 0.32 kilowatts. Next question, calculate the resonant frequency. Resonant frequency of the circuit of negligible resistance containing inductance of 40 millihenry and capacitance is 600 microfarad. Then F0, resonant frequency formula is 1 by 2 pi root LC. Here 1 2 pi root of L Henry is 40 millihenries, so 40 into 10 power minus 3 into capacitance is microfarad, 600 microfarad is 600, micro is 10 power minus 12. So by using careful calculation, we have 32,500 hertz, which is further equal 32.5 kilohertz. This is a resonant frequency of this circuit. Next question, a step-up transformer is used on 120 volts line to furnish 2400 volt. The primary has 180 turns. How many turns are in the secondary? The transformer formula is V1 voltage in primary divided by voltage in secondary is equal to number of turns in primary, number of turns in secondary. So applying the values, primary voltage is 120 and secondary voltage is 2400, which is equal, number of turns in primary is 180 and number of turns secondary is N2. Then by cross multiplying, we'll get N2 equal 180 into 2400 over 120, which is equal 3600 turns. 300, 600 turns in the secondary of the transformer. We need to get a voltage of 2400 volt output. So far we discussed about solving problem regarding AC circuit.